We're continuing section 4.4 with an application problem from Lehman's book, Intermediate and Beginning Algebra, page 210, number 48. The average salary for a hockey player in the National Hockey League was $1.8 million in 2008 and has increased by about $0.06 million per year since then. The fact that we see that we have the $0.06 million per year tells us that we have a rate of change. So we have dollars in millions, and this is per year. That is a rate of change because we see that ratio in the units, and that value is 0.06. Now the amount that we started out with in 2008, that's our baseline. So this is 1.8 million in 2008. Now the next thing that we need to know is which is our dependent and our independent. Well, our dependent value is the units in the numerator of the rate of change. So this is the thing that they've said is the average salary in millions of dollars. So our dependent is our S in millions of dollars. So I'll put dollars and I'll put millions like this. And then our denominator is our independent value. Those are the years. And it tells us that T is the years since 2008. So T is our independent variables names. And this is years since 2008. And we need to put that in there because that is absolutely relevant. So now we can build our model. Our dependent variable's name is S, so we'll put that in, plus our baseline, which is 1.8, and then plus our rate of change, which is 0.06, and then our independent, which is named T. And there we go. Now we have a model. So the first thing is to find an equation of the linear model to describe the situation. And we have done that. Now our next thing is to predict for 2013. So with our model for S is equal to 1.8 plus 0.06 T. What we want to do is predict for 2013. So 2013 is 5 years from 2008. So that's the first thing that we have to decide is what our T is. So T is equal to 5 in this particular case. Now remember that I talked about this in class, that we could write this as the value of the dependent with relation to the independent. And so I could say that we're finding S of 5 in our prediction here, which means evaluating this for the 5. So we have 1.8 plus 0.06 times 5. And so we have 1.8 plus 6 times 5, which is 30. And then we have 2 decimal points, so this is 0.30. And 1.8 plus 3.3 is 2.1. And this, of course, is in millions of dollars. And so that's what we say in terms of our units on that particular value there. And then it says predict the average salary will be in 2.2 millions. Well, that's saying that we want to know at 2.2 million for the salary. So that's telling us this one right here. So when we're doing that, this being 2.2 is the other way around. So 2.2, oops, that really didn't turn out well. 2.2 is equal to our linear equation, 1.8 plus 0.06 times whatever our independent is, and then we'll be able to predict for T. Well, you see, this is just a linear equation in one variable, which we now know how to solve. We didn't know how to do this before, so we couldn't even do these type of problems. So learning how to solve a linear equation in one variable has opened up new fields for us. So we now have 0.06t is equal to 2.2 minus 1.8, so I'm going to have to borrow to do this. So I'm going to end up with 0.4. And this is actually